Hey everyone, good morning, good afternoon, and good evening. Wherever you're joining us from, we're happy to have you. Thank you for joining us today. We're just getting started, people trickling in. I'm Devika Garre, lead marketing at TileDB. I'm very excited to bring you our year-end tech talk. We've had a great run, and so glad to be ending with a bang. We're announcing our TileDB and Snowflake partnership. We're going to talk about connecting complex data with Snowflake and TileDB together. And we're very lucky we have with us Kelsey McLeod. She's the head of Life Sciences AI at Snowflake. And we have our very own Seth Shellnut, Chief Technology Officer at TileDB. We do have this little QR code here if you'd like to scan it. Seth says there's a Bitcoin if you do. And there's it leads you to our Medium blog that tells you more of the Snowflake and TileDB story. And there's also a link to the blog in the chat. Before we dive in, a couple of housekeeping notes. Please, if you have questions, drop them in the Q&A panel and we will address them towards the end. We have a very exciting agenda for today. We're going to be talking about multimodal data and its role in precision health and drug discovery. And Seth is going to take us through how TileDB does that, and followed by Kelsey, who's going to talk about Snowflake AI Data Cloud and their positioning in healthcare life sciences, followed by the TileDB and Snowflake Better Together story, where we will have live demos and then Q&A and call to actions. Before we jump in, if you would humor us, we always like to get a little, check-in with a few opening poll questions. It gives us the temperature in the room. We have a few different questions, like, do you use multimodal data? And what do we mean by multimodal data? It's, data across healthcare life sciences is diverse. We have genomics, multiomics. So do you use all of those data in your workflows today? Is that data spread out across multiple environments? And then last one, are you using agents? How are you thinking about agents? So if you could take a couple of minutes, please. And yes, this event is being recorded. We will have a recording available. So yeah, we are getting some responses. Said Kelsey, is this kind of like almost the end of the year? Is this the last webinar for this year for the two of you? Do you have more?
I think this might be the last one for the holiday break.
Same, definitely. Looking forward to the holiday break, but still have a couple more weeks of exciting things to do.
Yeah.
Including this.
Including this one, yes. Okay, we have a few responses. Mira, how about we push them live? Okay, great. So we're seeing kind of across the mix, right? Across the board. And Seth, Kelsey, please feel free to comment. So yeah, I think vast majority of people do use these complex data types, and kind of surprising on the data being spread out versus unified.
I actually think that's becoming the trend. We really do see this idea of interoperability and openness, right? Leaving the data at rest, leaving it where it is, and working with these technology systems like what we're going to be talking about today with Snowflake and TileDB to optimize those data pipelines, whether it's centralized or decentralized, and how you can bring advanced analytics, machine learning, or even AI into these multimodal workflows.
Absolutely. And agents, yes, absolutely. So I think vast majority, everybody is in the experimentation phase. And we're going to show a demo here. Very exciting. All right, I think let's dive in. Thank you so much.
Yeah, thank you, Devika, for getting us kicked off here. And thanks to everyone for answering those poll questions, because they really help us to dive in and talk about some of the specifics. The first thing that we really want to touch on is how important multimodal data is to scientific discoveries and to the value that you're trying to drive, right? Multimodal data has become the foundation to foster competitive advantages that you have in your organization. And it informs decision making from bench to bedside, right? Bringing across this, all of these data types and modalities really helps to drive this decision making. But unfortunately, multimodal data is terribly complex to use. You can see the graph that we have here, all of the connections between the different types of data sets that might be coming in and the opportunities and where they're used. It's a web, right? And a lot of this data is extremely valuable to be used all over the place. But this makes it very complex to deal with. It makes complex to build your pipelines, your decision making, your applications on top of this. And this complexity really leads to a lot of expensive infrastructure and tools that you're trying to build out to handle all of this, right? You end up with a large amount of infrastructure and tools across the board trying to wrangle this, which, as we just saw in the poll here, makes the AI strategy very difficult, right? So if you're trying to use agents, well, agents need to access tools and the tools need to access data. But if your data is all over the place, it can be very difficult to manage. But, as Kelsey pointed out, we are seeing the trend of trying to solve this. And this is one of the things we're very excited today to talk more about is how TileDB and TileDB plus Snowflake can really drive a solution to solve some of these complexities involving multimodal data. The other thing is that we're seeing a large trend, right? That multimodal data is the foundations of what people are trying to build today. But we understand that the data is continuing to evolve, and there's a world beyond multimodal, right? That we're trying to get to, right? The world of tomorrow. You've got to be able to evolve and handle the data as it's changing, handle the research as it's changing, handle the queries and questions that are changing and evolving over time. You have to be able to be extensible and integratable into a variety of modalities, right? Science is always evolving. New hardware comes online, new bench systems are available. The data of tomorrow will be different than the data of today. And that enables new questions to be asked, right? So you need flexibility and extensibility built into your system. And you've got to be able to combine everything together so that you can leverage the best-in-class tools, models, and AI compute and AI tools for the different compute workloads that you need to have in the system. And, historically, we've seen this, right? The world started with very structured data set. Then we kind of moved to semi-structured and unstructured, right? As we saw evolving data over time and people starting to recognize that, hey, there's a lot of value in everything that's coming in, not just traditional tables, that we started off with in the 1970s, but really every type of data you can get your hands on is highly important. And we see this evolving as the interconnectedness across the modalities, right? These data sets are not in isolation. They're not just a random file that lives on S3. It's not just a random table that has no meaning in the larger world. It's not just a random sample of genetic data. These are different modalities that are intertwined together to build out from the unimodal world where we started off in databases to the omnimodal world that we're moving towards, where everything can be connected together and you can really drive advantage across the board for what you're trying to achieve in the research and development that you're doing. All of this really leads to the AI and the evolving nature of AI today and the data that exists, right? Today, everyone wants to leverage AI and LLMs to query this data and to try to make sense of it. But you need certain infrastructure to handle this, right? Agents, LLMs, they have to be able to access the data. You've got to be able to have governance over top of this. But unfortunately, a lot of the data sets that exist today, they're siloed, right? They're in different databases, they're in different systems, they're in different hyperscalers. Things that are stored in files, they're all over the place, right? They might be in the cloud, they might just be in the lab. They could be in your local PC as you're running, bioinformatic workloads, running, R or Python code locally. This causes a large amount of issues. And when, as an organization, you are trying to bring AI into the world and to make access to all of these different data sets to train and learn across this and actually drive governance. And a lot of this infrastructure issues lead to bespoke solutions, right? You build certain agents for one particular modality, for one subset of the questions you're asking. in one team, right, in your organization, that another part of the organization has no idea about and can't access and can't understand. So you end up with a lot of bespoke solutions inside your organization, a lot of disconnected attempts at evolving AI to meet your needs. And this leads to a lot of expensive maintenance and a lot of difficulty in IT, right? You need a lot of different experts to do this. You end up with certain shadow IT organizations as you're trying to build out, from your business unit, you're trying to build out AI usage. You end up in a shadow IT organization, which really just means that, again, you've kind of fractured the organizational structure and you're limiting who can access the data and who can actually make sense of this data. This is a huge problem in trying to adopt AI, is unlocking the value of everything in a structured and governance way that meets with all of the compliance requirements. So this is where we like to introduce TileDB as the omnimodal intelligence platform, right? We've built TileDB from the ground up so that we can structure, govern, and analyze all data in a unified platform, right? Three main things that we try to make sure that we cover, and very important to bring AI and omnimodal intelligence, right? The first is you've got to start with end-to-end fair data management, right? You've got to have that structured governance and access control, compliance and regulations, and reproducibility across everything. And so TileDB starts with this very important concept. Then you've got to be able to run your bioinformatic pipelines and your analysis across all the modalities, right? Whether this is multiomics, imaging, clinical data sets, any of the public data sets that might be available. You need to be able to run these complex pipelines in a platform that builds on top of that fair data management. And then, of course, you need to be able to connect everything for foundations, connect everything to LLMs, and the foundations can build out agents and customization and fine tuning on top, right? So TileDB unlocks all of this potential by hitting these key milestones to enable you to run a diverse set of workloads in a way that gives you fair data management and sets you up to use the best-in-class tools as the AI world continues to evolve. So just a couple quick examples on ML and generative AI that we've seen, right? And when we talk about like best-in-class tools, at TileDB, we've taken an approach here, right, where we want to integrate into the AI ecosystem. It's evolving very rapidly, right? The latest models are changing every few months. A new model is released that takes the lead in terms of foundational models and LLMs. ML models themselves that you're fine tuning and building for specific purposes, those are also rapidly evolving. So we built out our ML and generative AI integration so that we can have integrations with things like TensorFlow and PyTorch. So, at the programmatic level, at the low level, if you're building out custom machine learning workflows, we have you covered. We've got those integrations. We're integrated into a variety of the NVIDIA ecosystem and tools, right? NVIDIA, one of the best in class for ML and AI. In our last webinar, we actually showed an example of using NVIDIA Rapids to access single cell data that's stored in the TileDB format. So we're really pushing a lot of integrations so that you can use those best-in-class tools. And of course, inside of the TileDB platform, you can build, share, and serve machine learning models. So you can have your model exist alongside your code, alongside your data, all in a unified platform. You can run your serverless machine learning pipelines. And TileDB, of course, has vector database functionality, right? TileDB, fundamentally, we have our data model based off multidimensional arrays. We do more than just arrays, but arrays are our foundational model in TileDB. And that gives us the native ability to do vectors and vector search directly in. And TileDB excels at this in a cloud-native serverless fashion. And all of this sets up the foundation so you can integrate TileDB and TileDB Carrara into the larger ecosystem, right? You've got all of your different levers that you can connect, and then you can take your private data in a structured and controlled way and use it with your large language models. And I'm very excited later on in the demo. Kelsey's actually going to talk a little bit about this and show some examples using Snowflake intelligence for exactly this type of use case. Okay, so TileDB Carrara, it serves as your end-to-end platform for multiomics and your workbench. So whether that's starting from the secondary analysis, right? When data comes in and you want to run your secondary analysis, TileDB natively supports Nextflow. We can run Nextflow pipelines directly in TileDB. You can also run custom functions, custom pipelines as part of our serverless task graph functionality. And that leads you directly into the tertiary analysis, right? Once you run your secondary, then you've got your omics data sets and your frontier data sets that you're likely to ingest directly into the TileDB, whether it's with our TileDB CF format for variants, or single cell, our imaging, or some of the other modalities that we have first-class support for. And then you're going to use that as part of your entire your tertiary analysis. And this is where connections to external systems and partners like Snowflake come directly in, because when you bring in that omics data in the TileDB, you're going to want to marry it with a lot of other data that typically lives in systems like Snowflake, whether that's publicly available data that Snowflake has on its marketplace, or that's phenotypic and medical record data, or any other of the analysis data that Snowflake might be a system of record for. And we'll showcase in the demo a little bit of this, of how you can mix and match, bringing in data from both systems together to achieve your analysis goals, and then ultimately do visualization and reporting on this. So a couple of our customers that we like to highlight specifically in this area is one with Quest Diagnostics, being able to show how TileDB can be used in the clinical settings and diagnoses, using both for imaging and genomics. We've got a great white paper that we published in a use case with Quest available on our website, really highlighting how we brought a multiomics approach to their R&D. And then Rady Children's Hospital is one of my personal favorites. We work with Rady on the Begins Consortium. It's a consortium for newborn sequencing. TileDB is a critical part of this infrastructure that allows them to do rapid whole genome sequencing of newborn infants to screen for critical disease and offer treatments with life-saving therapies that offer the ability to actually make an impact on babies' lives every day. So we're very happy with both of these, because they're use cases where you're actually in the clinical setting and you can actually see the impact that this software can have on an individual's life. Again, with Rady, we've got a paper up on our website that outlines the whole process of the Begins Consortium. There's also been several papers published in a variety of journals around that. Okay, with that, I'm going to hand it over to Kelsey, who will talk a bit about Snowflake and the AI Data Cloud.
Thank you so much, Seth. Hi, as introduced, Kelsey McClosh, Head of Life Sciences AI here at Snowflake. And for those that are not familiar with Snowflake, we are the data cloud, the AI data cloud, where we've really evolved exactly how Seth has said around how data has evolved, moving beyond structured data into multimodal and unstructured sources, images, text, etc., beyond data engineering into analytics, and now into AI and ML, and the applications and collaboration that are necessary to create an interconnected ecosystem within our platform. Our platform is a fully managed service, fully managed platform that is cross-cloud, but interoperable around those key platform capabilities through our marketplace or through other ways that we're starting to build these connective tissue with other technologies we rely on. Specifically to the life sciences arena, we globally as a company, we have over 12,000 customers. And especially as we talk about AI and delve into the new AI capabilities we've put in place from our agentic infrastructure, 60% of those, or over almost 7,000 of those customers, have already adopted our AI capabilities. So not only do we see organizations across the globe and across industries adopting Snowflake, putting it in place across different systems of data, but also tying those data strategies and data foundations now to these high-value business outcomes. Specific to life sciences, we have over 1,400 customers, driven in the momentum of this around the adoption, one part to the security and the governance and the regulatory compliance, whether that's HIPAA on the hospital or payer provider healthcare side, GXP, and also FedRAMP as we move into more governmental research institutions. And the momentum grows because of the ecosystem that exists. Life sciences organizations can take advantage of the fact that many of those in the ecosystem, technology, health tech or life tech, are building on or powered by Snowflake. And then it creates more and more ways through our Snowflake marketplace, for example, as Seth mentioned, to create ways to connect and securely share data. More towards that too, in terms of how we really define the AI ecosystem for life sciences, or the AI data cloud for healthcare and life sciences. It's that platform with that interoperable storage layer, elastic compute services. Now, as we add Cortex services on top of that, specifically around agentic data retrieval, and then all of the managed cloud services that come encapsulated within the platform. But the real niche way we are verticalizing and solving, for example, scientific research or accelerated R&D workflows is through that, plus the connection to our ecosystem, key technology partners or applications like what we're doing with TileDB, for example. And on that front, exactly towards what we understand from how we are working now in that multimodal, or as Seth has explained, the omnimodal application. When we really think of true scientific innovation, it's from coming together with multiple sources of data, whether that's structured, coming from Snowflake, or unstructured, semi-structured, and of course through the interoperability that can exist either through connected platforms or through open table formats, allowing the data to live where it needs to live and create optimized ways to put that into advanced analytics, machine learning, and AI workflows, not only for FAIR principles around self-service analytics or discovery of data under those FAIR governing principles, but also harnessing that multimodal foundation that allows it for multiple use. This is really where I think we're honing in on more and more of the value as we work with TileDB and others in this ecosystem for scientific accelerated research. Largely as someone who's worked in the bioinformatic and I was a statistical geneticist for several years working with GWAS analyses or tertiary analyses around biomarker discovery. One of the biggest constraints is that R&D is often very siloed. For example, in a life sciences organization, not only the R&D as an organization, and sometimes that's silos by design, necessities because of the regulatory compliance or governance that's needed to separate deep research data or patient data or molecular data from other components. But what we have seen as Snowflake as we have grown into the R&D life sciences space as well as the clinical space or the supply space, and as we think of an agentic layer on top of this, there is incredible value when you can break down those silos, not just across domain organizations, but also within. And so even within R&D, typically these teams are very siloed, exactly as Seth said, working with very different system niche tools. As they modernize and as they either come to cloud systems or come to new ways to work with specialized storage, like what the multidimensional sparse or dense arrays that TileDB supports, you have the requirement to have that level of global governance and cataloging and visibility. And what that unlocks, and what we've seen with Snowflake in the R&D space, is you actually can start having cross collaboration. Use cases that are fueled where you have far more than just the information that you might have for computational scientists in early drug discovery and development and virtual screening, for example. Now we can actually create this connective tissue to bring back signals, for example, the multiomic data that might be coming from translational or even all the way from clinical trials that feeds back into how you do that multi-objective virtual screening at the very beginning, speeding up this entire process of drug design and development. So this is really where I think we can hone in on some of those really key use cases, especially as we see precision medicine or clinical diagnostics and the granularity of multiomic data like spatial transcriptomics necessary for us to fuel these use cases. In terms of Snowflake 2, I would like to touch specifically what we'll be showing today in conjunction with Seth's demo is heavily relying on all of the new capabilities we've been adding around AI and ML. And so there's multiple levels here, exactly as how we've built a data foundation through RBAC, supporting everything we do through Snowflake Horizon, where you'll see integrations with TileDB. It's also the infrastructure that we have built both for large language models, but even more so, especially as we think of scientific discovery, those transformer models or those foundation models that are intelligent to single cell sequencing or intelligent to RNA. Or intelligent to biomedical imaging. Those also are components that feed into what we do both from the ML side as well as the AI side that can be surfaced up into applications fit for purpose for scientific research. Speaking of ML on that front, and this is a place too where you can start seeing where we've annotated the specific places where we really see that we are unlocking new integrations, where TileDB data in those specialized formats that really unlock that multimodal or omnimodal applications can be fed into what we have built with our Snowflake ML, which is now an end-to-end set of capabilities, including in where you could register models directly into our model registry for inference, or you can fully build models, especially with our container runtime, which is a pre-built environment that gives you optimized data loading as well as access to distributed ray compute clusters, as well as GPU clusters through the CUDA libraries. So this is a key place where we see this integration really providing value that you can bring in and work with this multimodal data with TileDB to fuel some of these new use cases, whether it's training, retraining, or just inference from some of those foundation models that are in Hugging Face, for example. When we move into the AI stack, this is really where we have built an enterprise-grade service, again, tied fully into what we have done with role-based access control, our governance frameworks, but also where we have native serverless hosted models from all of the key providers that allow you to keep your data within that secure perimeter and also scale up how you can quickly, almost at startup scale, build data retrieval agents, for example, with access to the model garden of all of the different models, including those that you might have fine-tuned or trained yourself that might come from that ML flows. Now, when we think of ingestion, this could be coming from all of the different ways we've built in connectors. It could be coming from Snowflake native tables. It could also be coming from the data lake components of open formats like Iceberg. And of course, now it can come from TileDB. And then we surface this to the layer of processing and retrieval with native agentic functions we have created in the stack. Cortex Search, for example, can search across public literature or scientific research or ELN notes so that you can extract out meaningful insights and create vectorized embeddings that you can surface up in conjunction with structured data, like an analyst, which uses semantic views or semantic layer around text to SQL to also surface up insights from a GWAS analysis. All of these things can be combined in order to create an agentic framework that can be deployed. Our agents can be deployed anywhere through MCP. We can also connect tools through MCP. And finally, we can surface this into interfaces like what Snowflake Intelligence is. One of the other components where I think we have interesting integration with what TileDB is doing, for example, on the scientific imaging, we are democratizing access to these multimodal data sets wherever possible. So not only can we offer up and serve the complex researcher or complex computational scientists through Python or Java, but we also can surface the ability to work with multimodal data to the analyst layer into native functions we've also created specifically to work with multimodal data in an SQL-like environment. So we could read the metadata or infer from or classify from the metadata that has been tagged or used by TileDB around scientific imaging or biomedical imaging in order to run simple pipelines around classifying, filtering, or summarizing, aggregating. And then finally, as we'll show today, the other component of this is democratizing this all the way up to just conversational insights. Snowflake Intelligence is our interface for building up that conversational insights or chat-like environment where you can surface an agent and that agent can have access to multiple tools that allow us to work with both those structured, unstructured, or multimodal data sources, including what's coming from TileDB. So this is what we'll be showing a little bit after Seth goes.
Thank you so much for that, Kelsey. And I think it's a lot of wonderful things that Snowflake has been working on as of late and releasing, especially in the AI space. So what we'd like to talk about before we jump into the demo real quick is just a couple of slides on how TileDB and Snowflake work together, right? And what are you actually going to be able to get out of everything? So one of the first and most important things we want to talk about is how the speed of collaboration and discovery can be accelerated with TileDB and Snowflake together, right? You've got an unprecedented level of performance for multimodal and tabular data. As Kelsey's just talked about, right, there's been a lot of ways to bring data into Snowflake. Now we can combine Snowflake data with TileDB data to achieve best-in-class performance across the board. You've also got a foundation for a fair stack that's compliant and simpler, right? Now that everything can work together, your fair compliance is simpler because there's a connected app that TileDB can work with Snowflake in a secure and trusted manner. And this really unlocks the ability to use AI across all of your data. You've got to be able to bring all of these different modalities in, as Kelsey was just talking about. And now with the connected app of TileDB and Snowflake, you can do that. And there's a few use cases we see right off the bat that we believe are going to see massive acceleration with the new connected app. All right, preclinical and target discovery for drugs, as Kelsey mentioned during her part of the presentation here, right? We see a lot of potential to accelerate drug discovery with this new connected app and combining all the data sets together. Trusted research environments, right? Being able to have the connected app allows us to extend the trusted research environment support that TileDB and Snowflake have built into a unified approach here that will allow you to have governance across the data, and of course, respect geographic boundaries. Both TileDB and Snowflake are region aware and have multi-region support to handle all of the different use cases around geographic boundaries and compliance that you might require there. And this also leads us to the last use case, just to highlight, is genomic precision medicine, right? Doing things like rapid analysis of whole genome data for bedside diagnoses of rare disease is something we see there's a lot of potential here. Now, these are just 3 use cases to call out in this webinar. I think there's probably hundreds of use cases we could talk about if we had a couple weeks worth of your time. But being respectful that we are starting to run low on time here, these are the 3 main ones we really wanted to kind of highlight, and we'll touch a little bit in the demos in just a few moments. All right, let's look at a quick architecture diagram. I won't spend too much time, but everyone always needs to understand and wants to know, like, how do these things actually work together? So from the infrastructure side, TileDB will be deployed out. TileDB runs on top of a Kubernetes deployment, typically in an Amazon account, but it could also be something like Microsoft Azure. Snowflake is deployed out, typically in the same hyperscaler. But really, the systems can be deployed anywhere and talk to each other. Most likely, you're going to be deploying these, in the same regions alongside each other for all of that compliance and governance aspects and geographic boundaries you need. But the connected app is a very generic connected app that allows you to have like a many-to-many relationship. So you can deploy multiple Carrara instances, multiple Snowflake accounts, and they can all kind of talk together. So you have a lot of flexibility in the infrastructure and architecture to meet whatever regulations and compliance you have from the infrastructure side. So how do we actually see this this kind of working? Well, here's a small example of kind of a flow diagram, right? If we see both the systems being able to interoperate together. So, on the left-hand side, first there comes data ingestion, right? You're bringing data off of the wet labs and the benches. And typically you're going to be producing a lot of different data, right? There's going to be phenotypic information that comes from patient medical records, integrations into other third-party systems for those medical records. You're going to get the actual genomic data or imaging data or single cell data or any type of the omics data that's coming out of the bench. And that data is going to be loaded both in the Snowflake and TileDB, right? Depending on what data it is, depends on where you're going to load it, but you're going to be, loading into Snowflake and TileDB in parallel. So you get best in class support from each one. And then the important thing here, right, is that we have catalog synchronization across them. So you see at the very bottom here, right, we've got the Horizon catalog, we've got TileDB's multimodal catalog, and we've set up the ability, which we'll showcase in the demo in just a moment, to synchronize between the two, right? So you have a complete picture. No matter which platform you're in, you can see and access the data and have the governance and details. Now, of course, ingesting data, seeing data is great, but you actually got to do something with the data. So that's really where the machine learning comes in, and the connected app allows for zero copy sharing between the systems, right? So we can read directly from TileDB, load it directly into Snowflake environments, running machine learning, running AI workloads. Vice versa, will also show, like from the TileDB side, running like a TileDB notebook. You can zero copy, you can fetch that data across the board. And access any tables or any other data type that you have, including machine learning models that might be stored in Snowflake. So we've got a true two-way integration here that allows for a lot of flexibility for how you can access that and how you can share the data between platforms. Okay, with that, I'm going to switch over and we're going to do a little demo here and showcase exactly how this looks in practice. All right, so let me swap screens here for just a moment, and we'll walk through this. Okay. All right. So what I'm going to walk you through is a brief overview of the connected app. I'm going to showcase how the connected app works, a little bit of the high-level functionality you get on both sides. I will show you a small amount of actual programmatic access across both of them. We have notebooks that actually run an example, genomic-wide association and variant analysis, which the output of these notebooks are actually going to be stored back into Snowflake and used as part of Kelsey's demo that she'll show. For the sake of time, I'm not going to walk through the whole GWAS, and I'm not going to explain all the details, but those will be available, and we will publish all of this information. To start with, at the high level, though, in TileDB Carrara, when you first log in, you'll come into your workspace and see all the team spaces and data that you've got available. So in this deployment that I've made for the webinar here, we've got an example organization called the PathoPixel. Imagine this is like a typical pharmaceutical company that's come in and doing a variety of research. So in my workspace, I have a lot of settings that can be done. So as an IT administrator or someone that's like setting up the infrastructure, I can configure the workspace and I can come in and set credentials and details and members and settings and single sign-on and all the things you expect, from like the IT side to configure. But one of the important things that I want to highlight is that in the workspace, I can also configure defaults, right? So for whether it's default credentials and storage details for like my Amazon account where things are going to be stored in S3 and the Amazon infrastructure, or also integrations, things like Snowflake. So here at the workspace level, I've already configured a Snowflake integration. This means that everybody that's part of my workspace and any part of the team spaces, they can access Snowflake through this integration. So I've got it right here. It's already configured. If I wanted to add another Snowflake integration, I can do that right here, right? I can click Add Resource. I can select Snowflake, and I can put in all the information required to make that connection. So again, this is very powerful because this allows you to set up defaults for your entire organization. So if you want to have the connected app available to everybody, you can do that. If you need to have multiple different Snowflake accounts or roles or settings, we support, again, a many-to-many relationship here. So you have a lot of flexibility in how you deploy this out to meet your compliance requirements. Now, of course, you don't have to configure Snowflake for your entire organization. Maybe you want to configure things at a more granular level. So that's where TileDB team spaces really come in. So a TileDB team space allows you to have an organizational structure for individual groups or teams or projects that you might want to have. Very flexible what you put inside a team space. Here I've got one called the Oncology Team US Boston, just mimicking a typical like oncology research group. I've got a similar team space settings where I can come over and, of course, have the integrations here too, where I've configured a second Snowflake integration specific to this team space. So this allows you to have flexibility. Like maybe only one business unit or one project wants to access certain details in Snowflake, right? Or vice versa. You want to restrict what's going from TileDB to Snowflake. So you have a lot of flexibility, again, at the different organizational structures and levels and project management that you might expect to facilitate all of this. So in TileDB catalog, what I'm showing you here is all the information and details that are part of this oncology team space that I've created. You can see at the top level, I've got things like a README. If I open up this README, it's a markdown file. TileDB shows previews for different modalities of data. So right here, I can see this markdown and I can see all the information here. I can also see things like any metadata that's associated with it. So even a raw files can have metadata in TileDB. Everything has capabilities and flexibility for doing that. If I actually open up one example, though, for my genomics data sets, we can actually come in and see some pretty interesting things where if I look at my variants, you'll notice that I've got a variety of different data. I've got some TileDB arrays, I've got some notebooks, I've got Snowflake tables, and a genomic data set. So one of the very powerful things about the connected app is that I can actually bring Snowflake data into the TileDB catalog. So here I've got two different data sets that I've loaded. They exist in Snowflake, but they're going to be shown here in my folder called variants. And I can open them up and I can see details about it. So here's an example ensemble data set. I can see the schema and all the information about that. I can also see the SQL editor and I can run an example. So if I want to just say, hey, let me get a preview of this data, see the first 10 records here. When I run this, we're talking to Snowflake. We're fetching the data. And should return here in just a second, showcasing the top 10 results that come back from this data set. You can also open it directly in Snowflake. So I can click this and just take you right over to the Snowflake UI, so you can see all the information there too. See the same details, tables, data preview, everything available directly in that system here. The table's taking a few seconds to load, but you guys get the general picture about this. The other nice thing too is you can come in and again, of course, see the different TileDB tables and genomic data sets that are available. This same type of information and previews are available for different TileDB data sets. One of my favorite examples is looking at a biomedical image. So if I come in here and look at this particular image, this is part of the Open Cancer Image Archive project. I can come in and I can actually preview this image live here. This image is stored in the TileDB format. It's a TileDB image that lives on S3 that I'm previewing from my my laptop here across the Wi-Fi, across the internet, right to the browser. I can pan, I can zoom, so it's interactive level here. But the nice thing is like all of these, this data that I'm showing you here is also available to view and access through our connected app in Snowflake. So if I actually switch over and look at the Horizon catalog, you'll see that we've got a bunch of different data sets, but one of them is TileDB Iceberg. So we've actually built out a connection to Snowflake, building out an Iceberg catalog. So TileDB, under the hood, we've got a lot of ways we can store data. We can store arbitrary files. We can store data in the TileDB format. And we can store things in like Parquet and other file formats. But from the catalog perspective, TileDB has its own catalog, but we offer interoperability in a variety of ways in external facing catalog APIs, whether this is a Delta Share API that we previewed in our last webinar, or here you can see that we're using the Iceberg catalog API to expose the internal TileDB catalog to Snowflake. Snowflake supports a variety of external data types and data sets. Iceberg is one of them. So here you'll see the basic structure that I was just showing. We have our oncology team here. We have genomics, variants, imaging, single cell. I can open up the details and see different tables and information available right here. So this allows you to then see the different data inside of Snowflake, access it, see the information. Now, of course, viewing it in the catalog is great, but what if you actually want to access the data? So we have, as part of our connected app, and some of the great work from the team and help the team that's been very helpful at the Snowflake side, we've built a variety of functions that are available in the connected app that allow you to integrate the data and bring it back into the Snowflake ecosystem so that you can then run further analysis, whether it's machine learning, AI, or as Kelsey will show in just a moment, Snowflake intelligence all the way at the top level. So here's an example of accessing genomic data. This is the variant data that we were just looking at and saw in the catalog in TileDB. I'm going to access it for one particular gene here, the AARS1 gene. And if I query this using our helper function here that comes as part of the connected app, we actually can get the results back here. And then, if I wanted to pass this to other functions, that's quite powerful. The same thing for that image that I was just looking at, which is one of my favorite things here, right, is this same biomedical image that we were doing. I can query and bring it right back here. Now, viewing the image pixels as a table output here, just seeing the X and Y positions and the color codes, not very useful or helpful. But the super powerful thing is what I've done right here. I can pass this directly to any of the Snowflake ML functions. Kelsey was just showing some of the new AI functions that are built in the Snowflake. So the output of my function here for image can be passed directly into an image analysis function on the Snowflake side. And then you can continue working from there. So a lot of flexibility of how you can pass this through to the ML and AI aspects that Snowflake has. All right, we're running a little low on time. So the last thing that I want to show just before I turn it over to Kelsey is that on the TileDB side, not only can I view the data through the TileDB catalog, but you can also access everything programmatically too. So just like I was showcasing how through Snowflake SQL you can access it, on the TileDB side, if I'm going to run like a Jupyter notebook, I've got one example here that runs through a workflow. This notebook actually showcases accessing the data to start with and then running a whole GWAS. For the second time, we're just going to showcase a little bit of the interoperability, and we'll make these notebooks available after this webinar for other folks to look at. So there's just a couple data sets that we'll access. That's the GVCF 1000 genome Dragon data set. This is an 11 terabyte data set that's available from the Open Data Project and from Dragon. And then we're going to access two different tables, the phenotypes and ensemble. These tables are what we were just showing. They live in Snowflake. And we're going to actually access them as part of the entire workflow directly from our notebook and from TileDB's task graphs and distributed compute to access Snowflake. So we'll import a couple of Python packages. I'll create a nice little function that lets me query Snowflake and get it back as a pandas data frame. And if I query the variant data, so before I run the whole workflow, what does variant data look like? So in TileDB, we offer domain-specific APIs for a lot of different modalities of data. Genomic data, folks like to use genomic-specific APIs. So we have a TileDB VCF package where I can open up our data set. I can select different fields. Genomic data sets, like variant data sets, can have 100, 200, 300 fields. So TileDB allows you to sub-select on only what you care about. And then I can issue like a query. So when I issue a query in our genomic API here, our TileDB VCF API, I can pass in the regions just like they are in the typical like bed file format. I can also pass a bed file if I want it, but here it's just one region and one particular sample. And I get it back as a pandas data frame here. Now, if I want to query the Snowflake table, I can do that right here from my notebook. Because again, we have a connected app that's two-way. So from TileDB, I can just write a SQL statement. I'm just going to select everything where the gene is the KCMQ2 gene. And I'm going to read this back into pandas and get it right back here and print it out. So I can access that ensemble data and I can view it right here. So what happens here is this makes a connection over to Snowflake where, again, the connected app authenticates me behind the scenes. We've got all the service accounts, roles, and authentication set up. So I can access any of that data and bring it right back here. And then, of course, I can build this out at scale, which is the most important thing to really highlight here. So if I want to access and use large-scale task graphs, I can write a SQL query again to access Ensemble. I can do the same thing for like phenotypes. So there wasn't a lot of phenotypes from 1000 Genome, but I could say select every female from the 1000 Genome dataset running a query here. And then we've got a lot of nice helper functions in TileDB that allow you to run like large-scale distributed genomic workloads and other types of one-line functions to do distributed compute. So here I'll use our nice helper function for TileDB VCF to read the variant data in a distributed fashion. I'll pass it in a couple of our parameters. That's the data set we want, the attributes. Now the regions and samples. Now the nice thing here is this samples and regions, these are actually our delayed SQL objects. So you see that I'm using the delayed function here. This is part of our entire task graph API for lazy large-scale execution. And this allows us to daisy chain entire workflows and even mixing and matching data sources and data integrations. So here I'm going to access Snowflake to bring it back. And when I ran this earlier, we can see the visualization of running all of this in parallel and then collecting the results here. So you can extrapolate this out. And again, we'll make available the GWAS and further analysis after this. But you can now connect TileDB datasets and Snowflake datasets, whether that's from the Snowflake side or the TileDB side, build out workflows and pipelines and run all of this. And the nice thing too is the output of all of this can be saved directly back into either datasets, right? I can save things back in the TileDB datasets if warranted, or save things back into Snowflake, native tables, icebergs, what have you. And the output of the entire GWAS actually, it does get stored directly back into Snowflake, which Kelsey is going to now show some pretty cool things about. So Kelsey, I'm going to turn it over to you for that.
Great, thanks, Seth. Let me share my screen now, and we will speed through some conversational insights agentic demos. Just a quick look at what we're going to show here, what we have built now that we have the return of that information from the GWAS done with TileDB is a couple different components. So we've used a data layer where we're also adding in Cortex knowledge extensions that we've created for PubMed and clinicaltrials.gov. So how you bring external or open scientific research or clinical trials to an agent, and we've built search services around those. We also have a Cortex analyst where we've taken back that GWAS study, those data sets, and built a semantic model around it so that we have text to SQL that understands the context of what these genes, these variants, these diseases, and associations mean. We've also added in a custom tool because we recognize, especially as you might work with clinical data, you would want to be able to go back and query that data from TileDB to get patients, for example, the number of patients that have a specific pathogenic mutation within a set of genes or a location. And we can query that with that tool using those same APIs that Seth showed. Quick look at a couple different components of how this works. One thing is if you have brought data to Snowflake, what we can do with our semantic models is build semantic models that can be published in FAIR principles that make it accessible to AI native or AI ready consumption into agents. Here, for example, is a look at the same source of data. Now, what we recognize with this is the semantic model that might tie this into clinical data allows you to build a framework around asking, for example, questions around clinical and genomic signals together. This can be surfaced up into an agent. Here, an agent looks like what we would build with, and while that's loading, I'll actually go over here. Looks like something that we can surface into into Snowflake Intelligence. Here we have an agent that has those sources available, and we can ask questions. Just for time, I'll ask a quick one. And while that's running, I'll show the results of it, which is probably not the question I asked. But here, for example, we can ask questions to the results of a GWAS or to ClinVar, or to other sources we're annotating our scientific research with. It can summarize all of those components for us. And then, of course, notably, what we can do when we think of tying in patient information. So outside of running the queries that might find all of the interesting results from our analysis, we also can see the components of what the demographics or cohort of patients that meet into this fall, especially if you're a hospital or academic medical research, what you can do around understanding their clinical journey or their patient journey tied to where they have variants associated. Now, let's really dig in with the last little bit of time, the custom demo that we have built, because what we recognize and understand, exactly as Seth said, genomics data is large. We don't want to be copying it or storing it in multiple places. We want the data to stay at rest. If your data is not in a native Snowflake table, most likely it's in an external stage or in TileDB. So we want to be able to show how we can bring back the GWAS results, but still build an agentic framework around accessing that individual patient levels, queries, or slicing from TileDB as well. So here's an agent that we have now built that we've described, given its identity in terms of description. We've also given it instructions on how to respond, and it has key tools tied to it. One, it has the results of that GWAS study in tabular form in native Snowflake tables that in this case could have been through the Iceberg connections or other ways we can connect with TileDB. And that data has a semantic schema now tied around it to describe how we would want to use this data conversationally. We also have tied in a search service here. And then most notably, we have a custom tool here where we're using those TileDB VCF APIs in order to query the slices if we want to ask that individual level location around mutations to TileDB. Now, what this can look like is also how you put in orchestration instructions. Because of limited time, I'm just going to go ahead and ask a really quick one, which I think was tied to one of the genes that Seth just showed a result around. So here you can see it starting to think about how it's going to answer this question. And then we can see just as well, while that's running, I will go over here and show what it would look like from the interface within Snowflake Intelligence. Here again, you have that agent, you have the different sources. And as you ask a question here, for example, with this, now that I have multiple agents and chat interfaces running, but for time, I will go back to this one. You can see this one now has brought back the results. Kind of still stringing out the results of what that GWAS study was specific to that gene. And more fully, we can also see a full process where we've asked a question specific to querying different genes associated with neurological phenotypes, summarizing those pathogenic variants or mutations. And then once we have an understanding around the different results or components, we can also ask those complex questions to corroboration of public research like PubMed around how these specific genes or these mutations are involved in specific investigational or existing drug pathways. I want to give time for question. I know that was fast as possible, but I think that gives an idea and an insight of how we are connecting this, not just in terms of the data foundation, but agentically creating this connected ecosystem with TileDB and Snowflake.
Thank you so much, both of you. And I want to thank the audience for all the engagement. We have a ton of questions in the chat. We've answered a few down there, but okay, let me read out. What is, let's say, is Workspace and Teamspace able to cover work data teams globally? I believe, Seth, this one is for you.
Yeah, so you've got a lot of flexibility with workspaces and team spaces of how you configure your users. We have integrations with single sign-on, things like Okta, Microsoft Intune ID. You can use things like the SCIM SCIM protocol for automatically configuring this. You can, of course, manually configure this thing, user accounts and permissions too. So this allows you at the workspace and team space level to configure who can access what, to create as many team spaces as you want, to subdivide them into projects and regions, and to have any automation around that. So there's a lot of flexibility that can be offered there. And then, as I mentioned, that flexibility of like per team space configurations extends to the connected app, right? So you can have one team space access, one specific role inside of Snowflake that might restrict what it can do. A second team space, maybe in the European market, accesses a different Snowflake role. So you have a lot of permutations that can allow you to achieve the governance structure you're looking for.
Great. And then we have what methods are in place to integrate or access external data sets that you do not want to copy onto the cloud?
Yeah, so I'll take this, and then Kelsey, you can anything you'd like. But TileDB has a lot of different ways to access data, right? And we can access data that's stored in the cloud, as we just showed on this webinar. But TileDB can also be deployed, in on-prem, on device. We have different levels of where you can deploy out and how you can manage that. And then you can selectively connect to the cloud, maybe do a hybrid style approach. So I think there's a lot of permutations of how you can kind of manage this hybrid environment that we see a lot of different pharmaceuticals and people in healthcare and life science want to do, especially when it comes to governance of the data itself and rules and regulations about where that might go. So I think very happy to, if whoever asked this question wants to reach out, we're very happy to talk more specifics with you.
And specific to the Snowflake side, Snowflake is a fully managed cloud service. We're interoperable and work cross-cloud. But we have opened up that ecosystem in terms of how we can connect, of course, to cloud storage, blob storage, and S3 bucket, for example. But also, we have built a new component that's built on open technology, Apache NiFi, called OpenFlow, that's really also helping to streamline ETL or ELT pipelines where you might need to be bringing in data from those traditionally siloed or otherwise walled garden sources. So we really have opened that up. And then, of course, we work through open table formats in that data lakehouse framework, whether it's Delta tables, Iceberg tables, Parquet, et cetera. Often what we will see with anything unstructured or with the biomedical imaging, a lot of folks have started working with the optimized ability to store in cloud formats or in a bucket. And that's usually where we would connect to those sources.
Yeah. All right. I just want to say we can stay back and for 5 minutes and answer all your questions. So please, if you can stay with us, that would be great. Otherwise, email us. I've dropped that email in the chat, and we make sure that your questions get answered. So this next one, does the TileDB and Snowflake Connected App include agents by default, or is that something that I need to build custom?
Great question here. So as part of the connected app, we have a whole roadmap along with Snowflake around really building out the agent functionality. So what we showed you is the beginning of our connected app. We've got some functions that are available that can be hooked up. I think there was also a question about using TileDB with ML and histopathology and all I saw in that. So a lot of this we are building out today, right? We've released the connected app. You can connect the systems officially now, but we've both on the Snowflake side, and Kelsey, if you'd like to comment about agents, I know there's a big roadmap on the Snowflake side and on the TileDB side to really make these agents available, pre-populated first class, and to build out the functionality for you to customize as you go. So we've got the foundations of that today, and we're planning to keep working and releasing over the next few months. And Kelsey, I don't know if you want to add anything there.
Yes, and I'm also trying to answer some questions online so we get everything answered. But exactly that. What we recognize is there's been this rapid evolution. Even just a year ago, we're like, can we trust Gen AI? No one's even talking Gen AI anymore. We're talking agentic. Why, especially for life sciences, are we talking agentic? It brings a level of determinism because now we can have an LLM as a reasoning and orchestration layer that speaks to a set of tools. And now we can build an agent that brings in very highly structured tools, very unstructured tools, or custom tools like the connector we showed, and surface it up to create something like an agent. Now we're in multi-agent systems, and that's where we understand that no one system is going to build every single agent. We are working bidirectionally through MCP server, and that's really going to build up the agentic ecosystem as well. And the partners like TileDB, where we love to see the evolution is beyond data, beyond an application, is actually to how we are interoperably sharing or working with agent to agents from different platforms and different technologies.
Yeah, and I'll just add too, since Kelsey mentioned MCP, right? I mean, this is where we really want to take the connected app of TileDB. It's not just about the catalog and data, but as we talked about the agents, MCP, agent-to-agent protocols and all, you're going to see the connected app evolve to continue to allow all that type of cross access between the systems.
Right. How can Snowflake work with TileDB's array data with ML and foundational models? How can this be used for data sets like histopathology, medical imaging, and others?
Can start out a bit there, and Seth can add. It was really brief and really quick, but one of the things we're really excited about in terms of democratizing this is our AI SQL, AI SQL. These are like native agents we've built ourselves essentially, and all of those work with imaging data. So it's a place where you can work with multimodal data. So it could be reading or parsing and working just with the metadata of those images. So then you could say, hey, I need to find, or putting it into a query. Say, I need to find patients who have this very specific pattern or this level of like gene expression pattern from single cell sequencing data, for example, that shows damage to this tissue. So that's one way. And then the other way, as I had mentioned, is feeding it into our Snowflake ML components, where we can either train, retrain, or fine-tune foundation models specific to biomedical imaging or to other multimodal aspects that are coming from or connected to TileDB data.
Great. Let's see. There was a question about data. Okay, with 2 copies in excess storage. So our data always saved as 2 copies in Snowflake and TileDB, or so excess cost in storage. And I think the two of you answered that, sir, but I wanted to clarify.
Yeah, absolutely. The goal is that you don't copy the data, right? The kind of the whole reason that Snowflake and TileDB are partnering is that we see a lot of advantage of having the data accessible from both systems for your unified workflows, right? You don't want to have 2 copies of this data. Even if it's a really small table, the ensemble table or other things might only be a few megabytes. But as soon as you have 2 copies, you start having versioning problems, you start having lineaging problems. And you start having reproducibility issues, right? So no 2 copies, you're gonna have 1 copy and you're gonna query each other's systems live, as we kind of showed, right? Fetching data from one, bringing it to the other, wherever the compute is running, whatever your workflow is doing, you're gonna be able to unify that as part of your pipeline.
Ditto, exactly. Yeah, and that's again the unified governance in terms of cataloging and visibility. You always want a single source of truth, and we also recognize you want to have the data stored where it's optimally accessible to you from all systems.
Wonderful. Again, I think, Kelsey, you may have addressed this in one of your slides, but could I also query public databases, NCBI, in connection to my specific sequence?
Yes, yeah, and so we showed a couple things, some in terms of our own abilities to bring those in. A lot of it, if it's API, that's right. Just what we could do is write a Python UDF really to call to those APIs. So all of that is possible, but more so, what we're really excited about is those beyond just kind of where you have to create your own Python UDF and manage it. Is those that come into our marketplace and sharing data through our marketplace. And more than sharing data, but also sharing things like, if it's structured data, the semantic model that I mentioned. So the semantic or shared semantic models is now possible through our interface as well. And we've really put a lot of effort into opening that area as well. So we're part of the open semantic interchange, which means that you can actually think of sharing and working interoperably, not just with data from different databases, but the semantic understanding from a business context of those data sets.
How do you link that specific image to all relevant information of that sample in a context of a study or a project? More in the weeds, but Seth, Kelsey.
Yeah, this is a great question, because this also really kind of gets at the heart of the connected app and the 2 systems working together. Because typically you're going to have imaging in a variety of places, but as we showed today, TileDB is an excellent source to host that image, whether it's in the TileDB format itself or you're storing the files and managed by TileDB. And then you have the ontologies on top of that, right? You've got phenotypes, you've got patient details, medical records. Historically, a lot of those medical records and phenotypes have been stored in Snowflake as a system of record and source of truth. And as we just mentioned, right, kind of the goal of the connected app is that you're not exporting data out of Snowflake, copying phenotypes into TileDB, duplicating records to query, different systems. Instead, now, the biomedical images that are stored in TileDB, they can be accessed with the phenotypes, right? And you can do those joins and cross database queries, where you have, your cohort selection from your tables that live in Snowflake. Then you go over to TileDB to access the images that match those patients you've identified, and then bring that right back into an ML or foundational model that's running in Snowflake. So you can have that kind of seamless mapping through the system here.
And in sight to that, I showed it way too quickly, but one of the things we showed was our internal marketplace, which actually does have that observability through the cataloging to sources, whether it's in an external stage or somewhere else. But with that internal marketplace, it's a way to create data products, right? Data products where they have harmonized across possibly really complex sets of tables or unstructured information that's been embedded. And that's a bit of what I showed there with how you could push that, and you can actually publish that to your governance framework in terms of how organizations find that data product, which is not a separate artifact anymore, right? And so many times people think of legacy ways of data product, meaning, again, you made a copy, you took something, you harmonized it, and now you have another asset. This is actually on the metadata layer around how you leave the data as is, but explain it through metadata and can publish that.
Wonderful. That brings us to the end. Thank you so much, everyone, for joining. Thank you, Seth and Kelsey, for taking us all through all of this. This webinar will be available as a recording. So please, we'll send you a link and reach out to us. We would love to hear from you. Or the Snowflake and TileDB account teams will both work with you if you have use cases. And we do have a QR code if you'd like to scan that, but I also dropped the link to that in the chat. It's the Talk to Us link. So yeah, reach out. We'd love to hear from you. Thank you so much again. And we look forward to seeing you in the new year.